Hello everyone. Good morning. It's great to be here at RubyConf Thailand. My name is Roonglit, or you can call me Mac. I'm working for our team. We are a group of software developers that believe software development should be joyful. And this is cell-based architecture with Rails. Well, this talk is not about how to build the next Netflix or how to serve multi-millions of users. Our app actually isn't that huge. Instead, this is a story about a pretty normal multi-tenant Rails app that needs stronger isolation, especially for the enterprise customer. I will walk through what goes wrong with traditional multi-tenant setups and how cell-based architecture fix that, and then how we implement it in a very Rails-friendly ways. Okay, let's start with the pen. The classic multi-tenant app that many of us have we have one application, one database, and multi-tenant groups sharing the same stack. Right? And here are common problems that it could happen. First, the shared fate. Everything lives in a single application and database stack. If the database is slow, everyone's slow. Right? If the migration goes wrong, everyone's go down. One bad deploy can become a platform-wide incident. Second, the demanding customer. As bigger tenants arrive, they all want maybe slightly different features, custom behavior, sometimes even custom integrations. The more we change our codes to please that tenant, the more complex it becomes. It will become harder and harder to change anything without worrying about regression for someone else. Another point of failure. Now, the third is the noisy neighbor problems. When one tenant runs a big import or heavy blackout job, well, the traffic spike. They consume most of the resources. Then everyone else on the platform feels slower and no one's happy. The sad thing is, many of us will try to solve this loading problem, with scaling. When you hit the wall, there are two main scaling parts people talk about. On the left is the vertical scaling. You buy a bigger box, more CPU, more RAM, bigger database instance. This worked for a while, and it's simple, right? But it works. But it doesn't solve the shared fate problem. You still have one giant failure domain. On the right is a horizontal scaling. You run more instances, more spread traffic across them. This gives you better capacity and some resilience against individual machine failures. But logically, you still have one big application and one big database. So a bad migration or bad release still affect everyone. What we are going to look at is a way to scale horizontally in a more structured way. Not just a more server, but multiple cells. Each cell contains a stack with its own fate. Okay, now, let's talk a bit about the cell-based architecture. What is cell? A cell has everything it needs to serve a subset of your users. Its own application instances, its own database, its own caches and background workers, its own metrics and alerts and monitoring and everything. If that cell has a problem, we will go fix the problem in that cell while others still working fine. What we need next is something that will help us managing the cell, the control plane. The control plane is like a mission control for your platform. It knows which cells exist, which tenant or customer live in which cell, and which version of your application each cell is running. It's responsible for the life cycle of sales, creating a sale, upgrading them, and decommissioning the old ones. The data plane is where real user traffics go. Now you have multiple sales, let's say sale 1, sale 2, sale 3. Each one is a copy of the sale application stack, of the same application stack. But they can run in different places on different versions and serve different groups of tenants. In front of the cell, you have the sale router. It looks at an incoming request and designs for this request which cell should handle it. Common logic we would have is maybe sales by region, or let's say when you like very big. Imagine you run a global app which a customer can be across the world, in US, in Europe, in Asia. You could create a US sale in US region, EU sale in European region, and APAC sale in Asian region. The control plane store which region each cell is in, assign tenants to the right cell based on their location. And with the same architecture, another common pattern is to split by customer type. For example, enterprise sales versus shared sales. You might put your largest, most demanding enterprise tenants into their own sales. They get dedicated resources, more predictable performance, stricter SLA, and often a slower, more controlled deployment cadence. Keep smaller customers together in one or more shared sales. In that world, if a big enterprise customer runs a massive batch job or overloads their database, they impact their sale, but not every other customer on the platform. So in summary, we have a control plane that tracks sales in their metadata, knows which tenant live where, and orchestrates the lifecycle of sales. And the data planes made of multiple independent cells, each a self-contained stack for a subset of your users. Well, when we are talking about cell-based architecture, this is a picture that you will always see. Think about the platform as a chip. In a traditional setup, the hall is basically one big open space. If you get a hole, the whole chip floods and sinks. With cell-based architecture, you introduce bulkheads. You split the hall into compartments. If one compartment is flooded, the others stay dry. In software terms, let's say if the cell 3 might fail, maybe a bad migration, configure, or a regional outage, but cell 1, cell 2, and cell 3 remain healthy. That means an incident becomes contained that the blast related is one cell, not your entire platform. For enterprise customer, their environment isn't dragged down by some other tenant's problem. And if you do have an issue, it doesn't take everyone else with them. Before I jump into how we implemented the solution, let me, walk back in time talking about deployment evolution a bit. At the beginning, what we had, and I believe that you all had the same experience, we call the FTP era. Right? When you build your Rails app locally, then you upload files manually to a server. Either it could be FTP or maybe SCP or secure share into the box and Git pull on production, or you even edit the config directly on the server, tweak Nginx, restart Unicorn or Passenger by hand, maybe even edit code in Vim in production. Yeah, real man. It works, but it's high ceremony and high risk. No repeatable process, no consistent rollback story. It's easy for two servers to rip apart. Imagine if you trying to manage 10 or 20 cells this way. Secure share into each box will be a lot of work. It doesn't scale at all. So we move on. Now come to an era of Capistrano. We write the deploy.rb file, define role like web, app, db, and run cap production deploy. This was a big improvement. Right? Code is deployed via a repeatable script. We get releases with symlinks, current releases, chat. We can roll back to a previous release with one command. But Capistrano still expected that we manage the servers, OS packages, Ruby versions, system services, Nginx config, SSL certificates. If we have like 3 app servers, 1 DB server, Capistrano we deploy the Rails code to those 3 app servers, but you still have to keep Nginx config in sync, manage firewall rules, handle process upgrades. This is fine for 1 or 2 environments, but well, with multiple cells, it's not. So now come to the era of Docker and Kubernetes. We build a Docker image for the app, deploy deployments, services, ingress in YAML, and let Kubernetes schedule containers on the cluster. This gives us a great horizontal scaling, built-in primitive for rolling updates, health checks, self-healing, auto-scaling. That's natural fit for this architecture, right? Cell-based architecture. You can map each cell into a namespace or cluster, define resource limits per cell, and use the platform routing layer to send traffic to the right cell. But there's a trade-off. The learning curve is very steep. Using Kubernetes, you need to know Helm charts, service meshes, ingress controllers, secret management, cert manager. And for many Rails teams, this means now you need to have a platform team just to keep the cluster healthy. And if you are big, that's fine. Having a platform team is great. We have one. But you have a whole team for this. But if you are a small product team or a company with a modest ops budget, jumping straight from Capistrano to full Kubernetes can feel like going from riding bicycle to flying a commercial airplane. We want the benefit that cell-based architecture permits: isolation, resilience, per tenant or per region cells, but we don't necessarily want to run a complex Kubernetes cluster or build a large platform team. So the question we asked was, can we keep things simple enough that one person can operate it? Yeah, and we have Rails 8 and Rails 8 shipped with Kamau by default. Kamau lets a single developer handle deployment with a simple opinionated workflow. With one Kamau setup, you can get the zero downtime deploys, rolling updates so we can deploy new versions without interrupting users. Version management. Kamau will look into your Git revision and use that to versioning your Rails app automatically. So it's know if it's deploying the same code or not. And also accessories included. Kamau doesn't just deploy the Rails app, it also manages the accessory, something like Postgres, Redis, and also the proxy for you. And it handles the boring but crucial parts, reverse proxy, SSL, health checks. I still remember the journey that when I start using Kubernetes and I set up the cert manager just for get the free SSL from Let's Encrypt. Oh, that's awesome. But it's a lot of work on having that. But using Kamau, you get it instantly. Okay, let's walk through what Kamau actually do for the basic deployment. And when we run a Kamau deploy, there are really 2 big parts. First is getting our application image built and stored, and getting the image running on the remote servers behind the Kamau proxy. And Kamau automates the whole journey. Here's what it does. First, Kamau needs to make sure the remote servers are ready. It's secure shell and into the remote server for you, and then it check whether Docker is installed. If Docker is in there, Kamau will install Docker and do some basic setup. It makes sure that the server is in a good state to run the containers. This already replaced a lot of manual work. No more logging in, install Docker by hand, or doing ad hoc setup on every box. Once the server is ready, Kamau turn into the application itself. It takes your Rails code and build your Docker image. Usually this happens locally or in your CI using your Docker file. The image includes your Rails app, Ruby, and system packages. Any other dependency you have defined. So now we have a version container image that represents your app, ready to run anywhere. Then Kamau will needs that image to be reachable by the remote servers. So it pushed the image up to the container registry, Docker Hub, GitHub container, registry, AWS ECR, GCP artifact registry, whatever you choose. The result is a single version artifact that any of your servers can pull and run. With the image in the registry, Kamau go back to the remote servers. It secures shell into your server again. Then it tells Docker to pull the new image from the registry. Now, each server has a local copy of the new image, ready to be started as a container. You are not running Docker pull manually or track versions by hand. Kamau coordinates this for you. Now come the actual deployment step. On each server, Kamau will start containers from a new image and stop and remove the old containers. You can do this in a rolling fashion, bringing up new containers, wait until there's a healthy, then tear down the old ones. The goal is to keep your app available while swapping out the old version for the new one from your point of view. You just said Kamau deploy, but behind the scene is carefully replacing the containers so user doesn't notice. Finally, Kamau needs to make sure that the traffic goes to the right container. Kamau runs and manages Kamau proxy in front of your app containers. After the new containers are up and healthy, Kamau update Kamau's proxy configuration so it's point to the new containers and ensure the old containers are no longer receiving traffic. Kamau proxy is what enables zero downtime deploys, clean rolls out and rolls back. So in summary, a simple Kamau deploy is doing quite a lot. And for the cell, we could create a different configuration for each cell and let the Kamau know with the option D. Then Kamau will combine your configuration with the cell and use those to deploy your app to the right target. Okay. Well, that's for one server, right? And now we want to manage multiple cells. Then we need something else. Once we need more than one cell, we need something to coordinate them. That's where we develop a Rails control plane. This is a dedicated Rails application whose job is to manage the life cycle of our entire fleet of cells. Its capability are life cycle. It can create, update, and delete cells on demand. For example, spinning up a new cell for a big enterprise customer or retire that old cell that no longer need. It's versioning. It's track exactly which Git tag or image version is running on each cell. At any point, we can answer what version is the cell A on right now. Which cell are on version 2.1 or version 2.0. Orchestration. It can automate Kamau commands via API or background jobs instead of a human manually typing Kamau deploy for every cell. The control plane does it programmatically. And to prepare, Kamau deploys is do a lot of work for us. But to make it works with cell-based architecture, we need to break it down a little bit. So we need to prepare what version is in our system. For us, a version is just a git tag. When we are ready to release something, we create a git tag. For example, maybe version 2.1. That tag is our single source of truth. It's point to the specific commit, and it's a label we use everywhere else. Our CI pipeline then pick up that tag, checks out the code at the exact commit, builds a Docker image, and push it to our registry using command build push. The control plane never deploys whatever is on the main. It only works with the tagged version. In our Rails, we use that tag to represent the versions as well. So I can see this is on version 2.1. That literally means the service running on the container built from the image created from the git tag v2.1. With that in place, now we can talk about how the control plane chooses a version and deploy the exact version into a specific cell. Okay, we have command deploy, but we want to make our Rails app deploy another app using command. There's a problem that we have to solve. Our Rails control plane is also a Rails app, and it's also deployed with command. But we don't want the control plane to deploy itself to the cell, right? We want we want the control plane to deploy the app to one of our cells. So, previous step, we already have the image ready for on the repository, right? And instead of using command deploy, we can use command build pull instead. And we need to tell command on what we want it to deploy. So instead of using the command config on your Rails app, we need to tell where the configuration for our app to deploy. And then we use the Rails control plane to generate the dynamic configuration for a cell. So we can put the IP address of a specific cell, generate it on the fly, and then tell the command build pull to use that configuration to pull the image into that cell. So we keep the control planes or command config in the default config folder, and we keep the app for sales command config in a different folder. When the control planes want to deploy the app into the cell, it's called with just option C. Option C with tells command which configuration file to use. So instead of using the control planes, let's say this is how we say, hey, command, don't look at your usual config because we don't want to deploy control plane to the cell. Use this configuration instead. And second, we need the config to be cell aware. So each cell have the different servers, different IP. So the control plane will use that with the option D for specified destination of the cell. And lastly, because of the command actually this is designed to ship the application to a remote server. If we look into the Git revision of your repo and use that revision number when it builds and deploys the image, that's perfect for just deploying your single Rails app. But in our setup, the Rails control plane, we need to tell another version for to come out, so it will use the image that we already prepared for it instead of using the revision number. Okay, then we have the control plane to deploy our app into the cell, right? And now it's time for thinking about the cell router. Okay, like I mentioned, the command is really designed to deploy one application. In this default model, you run command from your app repo, it deploys the app, and it also set up command proxy on the same machine to front that app. For a single app, that's perfect. You get apps containers and run a proxy, and all living together on the same set of servers with almost no extra work. But our architecture, we want many cells, right? Multiple copies of essentially the same app, each running in its own cell, potentially in different regions or environments. We also want one common proxy layer that knows all the cell and can route the traffic to the right cell based on the tenant region or host name. So we end up with, well, if we deploy with the traditional way, we end up with the cell with a lot of proxy, but we don't need it that way. So we flip the model a bit by, instead of running command proxy inside each cell, we move command proxy out to its own computing resources. Think of command proxy as a shared front door that lives outside the cell and know how to route incoming requests into cell A, cell B, or cell C, depend on our routing rules. All right. Command itself will still use to deploy the app inside each cell, but the app image run app containers in the cell, manage versions per cell. But command proxy is now deployed and managed separately as its own service, and it's responsible for routing traffic into the specific cell instead of being tightly coupled into just one app deployment. This separation let us have many cells each deploy independently while keeping one central routing layer that can send each request to the right cell and give us a lot more flexibility as we grow. Okay, now we move command proxy out of the cell and run it as a separate service. We get a really nice side effects. We can now manage command proxy from our Rails control plane. And this worked out beautifully because of how command proxy is designed. Command proxy is built to be updated via command line. The command proxy command, we don't have to hand edit big config file, or we don't have to reload and restart it manually like we would with an Nginx. So we just instead use a command proxy command to deploy with the right options. So and it knows. The control plane secure shell into the server that run command proxy. From there, it's run the command like I showed you, command proxy deploy with the parameters that tell it which cell we are targeting and which domain should point to that cell. In other words, the Rails control plane is not editing config file, not manually reloading services. It just orchestrates a command line call to the command proxy. To keep it simple, there are really two key pieces of information we have to provide when we update command proxy. So it's a target where the cell is, it's a cell's IP or host, actually send traffic here, and the domain name, how we reach it, right? And which host name or domain should be routed to that cell. So we can have a domain-based routing. And another type of the routing is cell router by path. So far, we already did the domain things, right? And then we can teach it which path should be routed to which cell. We can define routing rules so that user in maybe Europe hit a European cell, user in Asia hit an Asian cell. We can evolve them over time. We can experiment with the different strategies, and we can change routing without redeploying the app itself. The big idea is command proxy gives us the mechanics of routing traffic to the closest computing power or to specialized cell for specific workloads, all managed from a familiar Rails app. Then when we have everything in place, we can deploy a specific version into specific cell and route traffic to them. Once we have this versioning in place, we can use it to build a nice staging strategy on top of our cell architecture. Instead of duplicating the entire cluster just to have a separate staging environment. We do something simpler. We designate one extra cell as an internal cell. The cell is only used by the team internal tester, maybe small set of beta users. The flow look like, see, I build the image with the tag version, Rails control plane deploy that version first to the internal cell. We test it, verify the new version there. If everything looks good, we take the same image tag and roll it out to other cells, one by one, according to whatever rollout strategy we like. This gives us a staging-like environment without duplicating the entire cluster or maintaining separate staging infrastructure. It's just one extra cell dedicated for internal use. Okay, so here's the big taking away from all of this. We solved the scaling problem with cell-based architecture, the deployment complexity with Kamau, and the orchestration with our Rails control plane. The beautiful part is that you don't need to learn Kubernetes or complex orchestration platforms to achieve the world-class scale. The entire solution is built on the Rails ecosystem. Following the philosophy of convention over configuration, this empowers small teams of Rails developers to build and operate applications that scale to millions of users. The tools are here, the patterns are proven, and the future is bright for Rails. Okay, and that's it from me. Thanks so much for listening. I hope this gave you a concrete picture of what cell-based architecture look like in practice, why it's a great fit for multi-tenant Rails app, and how you can get there with the Rails 8 Kamau and Kamau proxy. I also have a blog post on Medium. It would be nice if you go there, and it would be awesome if you give me a clap over there. Give me your opinion about it. Any feedback is welcome. And again, thank you.